Hello guys, welcome once more to another video in our YouTube channel. So in this video we're going to be solving a China mathematical Olympiad problem that was proposed to me by one of our YouTube subscribers. So this subscriber had a lot of difficulties in approaching this question and he sent it to me. So in this video I will do a resume and a detailed solution on this problem. So if you're just joining us for the first time, endeavor to like the video as you watch, subscribe to the channel if you're new, and also turn on your notifications so that whenever subsequent videos are uploaded, you'll be one of the first people to be notified to come and watch. Also share the video with your friends and as well comment in the comment section how you feel about the video. So I'm going to be using a method which is not unique to solve this problem because there are so many methods that can be applied in solving Olympiad questions. So if you have an alternative way of solving this problem, you can also write down what you think in the comment section, or you get to me with your alternative way and I might do a video on using your method and give credits to you. Learning never ends. Okay, so let's get started with what we have today. Alright, so I'll be very fast and explicit at the same time. Now we want to find all whole positive numbers that satisfies the equation 2 root 2 to the root x minus root 2 to the root y equal to 60. So the first recall I'm going to make is that if I convert a number in the form square root of x to a number that has an exponent, then I'm going to write square root of x as x raised to the power half, where the x is always positive. Now from there I'm going to convert root 2 and this other root 2 to 2 to the power half. So I'm going to have here 2 to the power half all that to the root x minus 2 to the power half all that to the root y equal to 60. The second thing is that if I take p to the cure and I raise everything to the power arrow, it gives me p to the power cure times arrow. So 2 to the power half all that to the power root x will definitely be 2 to the power half times root x, which is root x on 2. Same thing applies for 2 to the half all that to the root y. So doing that, we are going to have 2 to the root x on 2 minus 2 to the root y on 2 equal to 60. Now let us analyze this a bit before we know how to proceed. Now this is just saying that there is a certain power of 2, there is a certain number which if I take 2 to that number and I do the difference with the very 2 to another number, the result is going to give me 60. This is the implication of what this is saying. Okay, so definitely since 60 is a whole number, the first thing that comes to my mind is that this power here must be a whole number and this other power here must be a whole number. Okay, so I'm going to let those powers to be whole numbers, root x on 2 to be a and root y on 2 to be b, so that I'm going to have 2 to the a minus 2 to the b equal to 60. Come to think of it again, if you have 2 to the a minus 2 to the b equal to 60, it therefore means that 2 to the power a is bigger than 2 to the power b, because the difference is giving us something that is positive, something that is bigger than 0. And whenever 2 to the a minus 2 to the b, or whenever 2 to the a is bigger than 2 to the b, definitely a will be bigger than b. Okay, so a is going to be bigger than b. So if a is bigger than b, you take 2 to the power on both sides. You're going to have 2 to the a bigger than 2 to the power b, because the exponential function is an increasing function. Okay, yeah, the exponential function is an increasing function when the powers are positive, like in this case a is bigger than b, so 2 to the a will be bigger than 2 to the b. So since, like I said, we have 2 to the a minus 2 to the b equal to 60, it therefore means that a is bigger than b. And if a is bigger than b, and since a and b are all whole numbers which are positive, then A being bigger than B, it therefore means that we can just try to say that A will exceed B by a certain number. So you must add a certain number to B before you get A, because A is bigger than B and both of them are whole numbers. Okay, so from here all we need to do is, okay, we replace our A here with B plus N, and we replace B basically with B. Then we try to see what we have. So doing that, we have 2 to the B plus N minus 2 to the B equal to 60. Now the next recall we are going to take is that x to the n plus m is equal to x to the n times x to the m. A very basic recall from indices, so that we can express 2 to the b plus n as 2 to the b times 2 to the n, then minus 2 to the b equal to 60. From here we factorize 2 to the b from both terms. We are going to be left with 2 to the n from here, and here we are going to be left with 1. Okay, now it becomes very interesting. Let us again interpret what we have. Now what we have here is that we have 2 to a power times 2 to another power minus 1 is equal to 60. So when I look at this, what comes to my mind is what we call prime factorization. Now what is prime factorization? Prime factorization is basically expressing a number as a product of its prime factors, or as a product of the powers of its prime factors. Okay, so there are so many factors of 60, but the prime factorization of 60 is expressing 60 as a product of its prime factors. All right, but not necessarily, but all the prime factors of 60, we have to express 60 as a product of all its prime factors. In fact, the fundamental theorem of arithmetic states that every number can always be expressed as a product of its prime factors. Okay, so in this case, let us interpret this. 2 to the power b is a number which is even, because 2 to the power b means that you have multiplied 2 with itself b times. 2 to the power 1, 2 to the power 2, you have multiplied 2 with itself 2 times. 2 to the power 3, you have multiplied 2 with itself 3 times. So 2 to the power b, definitely you have multiplied 2 with itself b times. And if you multiply 2 with itself b times, the result will be a multiple of 2. And if the result is a multiple of 2, definitely it is even. So this guy here is even. What about 2n, 2 to the power n minus 1? Now let us focus on 2 to the n. The same explanation goes here. Since 2 to the b is even, it therefore means that 2 to the n will also be even. And if 2 to the n is even, it means that it can be written as a multiple of 2. So this 2 to the n can be written as 2k, alright, where k is an integer. So in this case, if we have 2k minus 1, the result is an odd number. That's basically the definition of all odd numbers. If you leave an even number to get to an odd number, you either add 1 or you subtract 1. Because if you are a whole number, you are either even or odd. So 2 to the n minus 1 is going to be odd because 2 to the n is even. This 2 to the b is definitely even. So I'm going to find a way to write out the prime factorization of 60 such that I have a certain factor which is a power of 2. Okay, in fact, this factor, we should introduce a certain factor of 60 that is not just even, but it is even and it's a power of 2. Okay, so in fact, we have to express 60 in this exact form, that is a product of an even number and an odd number, but that even number must be a power of 2. So definitely I'm going to write 60 as 4 times 3 times 2, because 4 times 3 is 12, times 5. 4 times 3 is 12, and 12 times 5 is 60. I'm introducing 2 squared because I'm having 2 to the power b here. So you are not just even, you are even and you are a power of 2. Okay, so I'm going to group 3 and 5 to give me 15, and 15 is clearly odd, so this is going to solve my problem. So 2 to the power b will be equal to 2 squared times 15. Equating corresponding entries, we have 2 to the b equal to 2 squared and 2 to the n minus 1 equal to 15. Now from here we can clearly see that b is equal to 2 since they have the same base. B will be equal to 2, the exponent, and here 2 to the n will be equal to 16, which is 2 to the power 4. It therefore means that n is equal to 4. Okay, so b is 2 and n is 4. How do I get a? Our a is b plus n, so 2 plus 4 is equal to 6. So we have gotten the value of a and we have gotten the value of b. The value of b is 2 and the value of a is 6. So let's go back to getting the value of x and y. So from this first from here we have root x is equal to 2a. From here we have root y is equal to 2b, but a is equal to 6. It therefore means that root x will be 2 times 6. B is equal to 2, so root y will be equal to 2 times 2. 2 times 6 is 12, and to get x we have to square both sides. So root x equal to 12. The value of x is just the square root, is just the square of 12, because we need a number that when we take the square root of it we get 12. So x will be equal to 144. Sorry, x is equal to 144, okay, and not 12. And then y is equal to, we have to square 4 to have 16. So the final answer is x is equal to 144. I'm sorry for the mistake, and y is equal to 16, or we can just say x is equal to 12 squared and y is equal to 4 squared. So you can check for yourself by replacing, in fact, if you replace root x with 12 and you replace root y with 4, then we try to simplify to see if the result is going to give us 60. Definitely it is going to give us 60. Alright, so we have come to the end of this video. If you love the video, make sure you comment in the comment section how helpful the video is to you. Subscribe to the channel if you're just joining us, and turn on your notifications. Like the video and share the video with your friends. Remain blessed and see you in the next video.